Hello everyone, I'm Frank and welcome to Learn How to Sudoku, where we take a very easy variant Sudoku puzzle and we break it down in detail so that you can learn how to Sudoku. Today's very easy puzzle is called Krenellations by Blobs, and here are the rules. We have normal Sudoku rules apply, which means in every cell in the grid, place a single digit such that every row, column, and designated 9-cell region contains the digits 1 through 9 exactly once each. Along the lines, specifically, white dots separate consecutive digits, and black dots separate digits where one is double the other, and not all such dots are shown. So, for example, if this were, say, a 2 here, this digit would have to be 1 or 4 to maintain the 1 to 2 ratio between them, because along this line, there's a black dot between these two cells. And if this were 2 here, this would have to be 1 or 3 here, because these digits have a white dot between them, so they must be consecutive. Also, digits separated by an x sum to 10, and not all x's are shown. So, for example, if this were, say, a 6 here, this would have to be 4, because these two digits must add up to 10, because there's an x between them. And those are all the rules. If you like to play along, there's going to be a link in the description. And now, I'm going to get started. Let's learn how to Sudoku. Okay, let's start with here. This digit is in a 1 to 2 ratio with 2 unique digits. So this can only be 2, which is in a 1 to 2 ratio with 1 and 4, and 4, which is in a 1 to 2 ratio with 2 and 8. So this is 2 or 4. That leaves this is 1, 2, 4, or 8 here. If we try to have a 1 here, that would guarantee this is 2 to be in a 1 to 2 ratio, but that would also guarantee this is a 2 to be consecutive with a 1. So this cannot be 1 here. So these digits are both even, and they are in a, and we're also guaranteed that this has to be 2 and 4 remaining. Oh, well, there you go. We have 2 and 4 remaining in row 9, and sorry, in this triplet of digits. Whenever you have 2 within a 1 to 2 ratio with 2 other, or you have one digit that's in a 1 to 2 ratio with 2 other unique digits, it's either going to be 1, 2, 4 or 2, 4, 8. So therefore, anything else that sees all of those digits will not have a 2 or 4. We know these two are even digits because you're guaranteed a 2 or 4 there, or 2, 4, 8 here. Well, in the rest of row 9, we have 2 sets of digits which are consecutive with each other. That means you're guaranteed 1 odd digit and 1 even digit for each of those pairs. That means we have an odd even here, an odd even pair here. We have 2 more evens here. That's 4 evens already guaranteed in row 9. That means we cannot, these digits have to contain 2 even cells. So this cannot be an even cell here because we already have all the even cells accounted for in row 9. This can't be even, so it's odd, and that's odd, which is in a 1 to 2 ratio. Sorry, it's consecutive with an even digit, so both of these are even. And we have 4 evens already accounted for here, so this cannot be even, it must be odd, and the only odd digit that could be here is 1. So 1 is in a 1 to 2 ratio with 2, which is in a 1 to 2 ratio with 4. That's consecutive with an odd digit here. And this digit adds up to 10 with another digit. Well, 5 only adds up to 10 with itself, so that's not possible in normal Sudoku. So this must be odd and odd adding up to 10. So this is 3 and 7. So we have 3 here. This is 7 there. These are consecutive. These are in a 1 to 2 ratio. And this cannot be 1, 2, 3, or 4. 5, 7, and 9 cannot be a part of a set of across a black Kropke dot. Because if you have 5, 7, and 9, you get 2.5, 3.5, 4.5. If you double 5, 7, 9, you get 10, 14, or 18, none of which are digits. So therefore, this must be a 6 or an 8, which is a 3 and a 1 to 2 ratio with 3 or 4. And we know this is even, because 6 or 8 is even here. Okay. What else do we have? These are consecutive. This is even. What else do we have? These are in a 1 to 2 ratio, so are those. What else? These are consecutive. These are consecutive. So that means that's 3 odd and even pairs in this left central box. Do we have anything else? Where is 7 in row 9? Cannot be here because of a 7 in the box, so 7 has to be one of these digits. Well, we know the even digits here are 6 and 8, right? 6 and 8 are only consecutive with 5, 7, or 9 here. So one of these, the 6 and 8 here can be consecutive with 5, 7, and 9. That means the remaining odd digits have to be 3, 5, 7, and 9, but 7 obviously cannot be here. So if this is 6 here, this has to be 5 with it to be consecutive. If this is 8 here, this must be 9 to be consecutive with it. Okay. We know 7's one of these. So this is 3, 5, 7, 9. This has to be consecutive with 3, 5, 7, 9, but it could be any of them, any of the evens. So could this. Okay. 7 cannot be here. Where is 7 in this central, lower central box? It must be one of these two. 7 is not consecutive with 3 or 4. So this can't be 7 here, which means this has to be 7 there. 3 here would force this to be 2 or 4 to be consecutive with it. But we already have 2 or 4 in the box, so this can't be 3. It's 4 there, which makes that in a 1 to 2 ratio with 8. 4 is even here, and these are both even here, which means this must be odd to be consecutive with it. It can't be 3 because of 3 in the box, so this is a 5. 6 can't be here because of 6 in the column. Where is 6 in this lower central box? It must be here. So this is 6 and 4, adding up to 10 here. So that's 6, this is 4. That means no 4 or 6 here, no 4 or 6 here. We're left with 2 and 8. For the evens, we have 4 evens now in row 8, so the rest are odd. 7 obviously is an odd digit. This is odd. This has to be a 9 because there's no other digit remaining, and we're left with 1 and 5 remaining in row 8. Okay. So one of these, it has to be 2, which is consecutive with 3. One of these is 8, which is only consecutive with 7 or 9. So 5, obviously, cannot be either of these digits here, because that's not consecutive with 2 or 8. Okay. What else do we have? These digits are consecutive. Does that help any? Not particularly. Remaining digits of column 5. We have 1, 3, 5, and 8. 5, as I said, cannot be part of a black crop key dot scenario. So we could have 1 here, which forces this to be 2. We could have 3 here, which forces this to be 6. We could have 8 here, which forces this to be 4. But this cannot be 4 because of 4 in the column. So this can't be 8. Therefore, this is guaranteed to be an odd digit. This is guaranteed to be even digit, which makes this odd. That makes that even to be consecutive. 1 cannot be consecutive with 2 other unique digits because it's only consecutive with 2. So we could have 3 here. That would be, this can't be 4 because of 4 in the column, so that would be 2 there and 4 there. 5 can have 4 and 6. Again, 4 can't be here, so 4 would be there, and that would be 6. And 8 can be consecutive with 7 or 9, which any of those could be. Okay. So we're guaranteed an 8 here in column 5 and a 5 here in column 5. Okay. 2 and 6 is consecutive with either 1, 3, 5, 7, which could be consecutive with any of the even digits, so that's fine. 7 eliminates 7 in the rest of the column here. What else do we have? For this to be a 1 to 2 ratio, it's either 3, 6 or it's 1, 2 because we can't have a 4 in the column. That means if this is 1, this would be 2 here. If this is 2 here, it cannot be 1 because of 1 in the column, so it would be 4. If it's 3 here, this would be 6. If this is 6 here, that would be 3. So what digits here are consecutive with... this has to be an even digit because it's consecutive with 1 or 3. So this has to be 2 or 4. So this is 2 or 4, which can only be in a 1 to 2 ratio with 1 or 2. So this can't be 3 or 6 here. Therefore, we're guaranteed a 2 here. Because it's either 1 and 2 in a 1 to 2 ratio or 2 and 4 in a 1 to 2 ratio. So this can't be 2, it's 6. 6 is in a 1 to 2 ratio with 3. 6 is consecutive only with 5 out of 1, 3, or 5. So that's consecutive with 4 or 6. 3 eliminates 3 in the rest of the column. 5 eliminates 5 here in the rest of this row. We have a 1, 5, 8 triplet in this upper central box. 6 eliminates 6 here. 2 is not consecutive with 5 or 8. So this cannot be 2. We can't have 4, 5, and 6 to be consecutive here. So this can't be 5, which makes this 8. That's consecutive with 7 or 9. So 8's even here. These are both odd. 8 eliminates 8 here, so that's 1, which makes that not 1. It's 5. 1 eliminates 1 here, so that's 2, which is in a 1 to 2 ratio with 4, and in a 1 to 2 ratio with 1. So we have even here. These are both odd. Remaining digits that we have left are 2 and 3 in this upper central box, which adds up to 10 with 7 and 8 respectively. 7 here in this column eliminates 7 here, so that's 8 and 2, which makes this 3 and 7. 2 and 8 are both even. 3 and 7 are both odd. 1 is odd. Okay, this is in a 1 to 2 ratio. It cannot have 2 or 8 in it. That eliminates 1, 2, 2, 4, and 4, 8 as pairs in a 1 to 2 ratio. So this is 3 and 6. That eliminates 3 and 6 in the rest of this row. So we don't have 3 or 6 available. We don't have 4, 8 available. This is either 2, 4 or 1, 2. Either way, we have a 2 guaranteed here. Okay. 8 eliminates 8, and 5 eliminate 5 and 8 in the rest of the column. If this is 9, this is guaranteed to be 8. If this is 6, this is guaranteed to be 5. Okay. Remaining digits of row 3. This cannot be 3 or 7, so this must be an 8, 9 pair. And this is then 3 or 7 here. If this were 9 here, that would force this to be 1 to add up to 10, but that's not possible because of 1 in the box. So this must be 8 here, which makes this a 2, which makes that 9. So this is odd. We have evens here. This is 3 or 7, which must be with 3 or 7 to add up to 10, but this can't be 3 because of 3 in the row. So that's 7, that's 3, that's 7. This is a 1 to 2 ratio, but you cannot have 2 in it, or 1. So it's either 3, 6, or 4, 8. So if it's 3, 6, this is 3, and that would be 6, because 6 can't be here because of 6 in the row. If it's 4, 8, 4 would be here, which would force 8 to be there. So this is guaranteed to be even. This digit is consecutive with this digit. If this were 3 here, we already have a 2 in the box, so 4 would have to be here. And if this is 4 here, we can't have a 3 because of 3 in the row, so this would have to be 5 here. Either way, we're guaranteed one of these is a 4. Where is the 4 in this upper left-hand box, then? It can't be here because one of these is a 4, so 4 has to be here, which leaves us a 1-5 pair remaining in this upper left-hand box. 5 can't be here because of 5 in the row, so this is not 5, it's 1, which makes that 5. 5 eliminates 5 here, so it's 4 and 3, which is in 1 to 2 ratio with 6. This can't be 3 or 9. It's 7 left, which is not consecutive with 2, so this must be 8. That makes this left a 2 in column 1. 7 eliminates 7 in the rest of this row here. This can't be 8 either. So therefore, this is a 5-6 pair to be consecutive. That eliminates 5 and 6 in the rest of the row. So this can't be 6. It's 9. That eliminates 9 here. That's 3, and this must be 8. That's 3 in the corner. We celebrate because we're close to solving it. This 5-6 pair eliminates 5 and 6 in the rest of the box. So this can't be 5. It's 1, which makes this 5. 2 is consecutive with 1 or 3, but this can't be 1 because of 1 in the box, so this is 3, which adds up to 10 with 7. 3 eliminates 3 in the column, so this is 6 and 3. 6 eliminates 6 here, so it's 5 and 6, which leaves this digit as a 9. Remaining digits in this lower left-hand box is a 9, which is only consecutive with 8. 4 eliminates 4 here, so it's 6. Remaining digits. In row 7, we have 1, 4, and 6. 6 can't be here because of 6 in the column. 1 would force this to be 9. 4 and 6 would force this to be 4 and 6, but we can't have 4 and 6 there because of 4 is 6 in the row. So this has to be 9, which makes this 1, which makes that 4, which makes that 6. 8 eliminates 8 there, so it's 2. 4 is consecutive with 3 or 5. 5 can't be here because of 5 in the column, so this is 3. 4 eliminates 4 here. 1 eliminates 1 here. This has to be 1, 2, or 4. But it has to specifically be 1 or 4 there. 2 cannot be in a 1 to 2 ratio here, so that eliminates 2, 2, 1, 2, 4, and 3 and 6 can't be here because of the 3 or 6 in the box. So this has to be 4, 8 in a 1 to 2 ratio. So 4 has to be here because it can't be here because of 4 in the row. So this is 8, which makes that not 4. It's 1, that's 2, that's 4. And the rest, well, okay, we have one more thing. This is consecutive with 4, so this must be 5. Now the rest is normal Sudoku. Remaining digits in column 7 are 1. We have 8 ones. We know where the last one has to be. It has to be there. 2s. In column 8, 2 can't be here or here because of 2 in the boxes, so that leaves us a 2 there. We have 8 2s, so the last 2 has to be there. 3. I think we have all the 3s. 1, 2, 3, 4, 5, 6. Yes, we do. 4s. We have 9 4s. 5. The remaining 5 in column 3 has to be there. We have 8 5s, so the last 5 has to be there. 6s. We have 8 6s, the last 6 is there. 7. We don't actually have enough information to disambiguate the 7s. Okay, so let's continue. 8s. We have 8 8s. We know where the last 8 is. It has to be there, and that should help to disambiguate things. 9. In row 4, the 9 left is there, which makes this 7, which makes that 9. And that gives us 8 and 9, so the last 9 has to be there, which leaves us a 7 here. And that's a solution. Fairly straightforward. Yeah. I just liked it because of the pattern, the crenellations that were here. Is that the way you actually spell crenellations? I thought it was with a C. Huh. Let me look this up. Yeah, crenellations is normally with a C. So I guess that makes sense because these are crop key crenellations. And what a crenellation is basically a wall pattern, a defensive wall pattern, which is this is sort of like taking like the bird's eye view and looking down at like a castle. And yeah, nice little puzzle here, especially with the K crenellations. Anyways, I hope you enjoyed this episode of Learn How to Sudoku, and I'll see you next time on Frank Puzzles. Take care.